Welcome once again. We are essentially finishing our discussion on integration, on which we had a huge one. After this we are going to discuss something which is very fundamental and where we are going to make a transition to higher calculus or analysis. So here we are trying to answer this very important question. You have seen that there are many functions which are not the derivative of some other function. So you cannot use elementary methods of integration to really speak about them. So in such cases, what are we going to do? Is it that we can't find the value of the area of such functions? Maybe they are non-negative functions. Can't we find the value of the area under such functions? Can't we do that? Or can we not even try to get an estimate or approximation of what is the area? So for such cases, for example, if you talk about say e to the power minus x squared dx, as we told. So this is a perfectly nice continuous function. So if I want to know it, and it is positive, and if I want to know that what is its area between 0 to 1, what is the area under the curve, I just can't do it by elementary methods because either it is not a derivative of any integral of any function. So it is not an antiderivative, you can't find its antiderivative. So in such cases, what is the recourse? What recourse we take? And the recourse that we take is numerical integration. That is, we will use some technique. It is the same technique by which integration is defined to build sort of rectangles and then try to find the area, and we say okay, this is a good estimate of the area. So first is the trapezoidal rule, where we view things in the following way. So we consider a function f from a b to r, and f of x is greater than or equal to 0 for all x. This is a sign of for all, this is inverted A. So maybe the function is something which we are not so for such functions where we do not know the antiderivative, this is a very useful tool, and in certain cases the function would not be given to you. For example, in physics it is well known that temperature is a continuous function of time, right. So as time varies, say you take the time now t equal to 0 and you record the temperature till midnight, say from 12 to in the noon, and then you record the temperature, you would see it varies. So if you, as you see, if you make your two recording time difference very small, the temperature variation is very small. So from those sort of experimentation, physicists gathered the fact that the time is temperature is a continuous function of time, and obviously it is non-negative. But suppose you just record the temperatures, you do not know exactly what is the relationship, right. Then you want to know what is the average temperature in the day. How do you do so? And it's exactly in those sort of situations where numerical integration actually comes into play. So here let us look at this function. So here is my A and here is my B. Don't bother too much about the drawing, I am just trying to make it look. So let this be the function, right. So this is my y equal to fx. Now this is a graph. So what I do in numerical optimization, numerical integration techniques, what I do is that I divide A and B into equal intervals. I put partition points in such a way that this difference between this AX1 length is same as X2 X1 length and so on and so forth. And I will say that, though it might not look in the picture, each of them has a length delta x. So, in this partitioning what I have done is, so delta x, so suppose I have n partition, so delta x is nothing but so this is what delta x, so a whole b minus a is divided equal into n partitions. So, each partition of length is delta x, so there are n partitions, so n into delta x is b minus a, because there are n minus 1 points taking a and b into consideration. Now, what should be my next step? What I want to do? What is the meaning of trapezoidal rule? So, you know of this term called a trapezoid from Euclidean geometry. So, we are going to build trapezoid. So, we are going to build trapezoids. Instead of building rectangles, what we had done while we are trying to explain what integration is all about, we build rectangles, build the trapezoids. So, trapezoids are, if you want to recall, are quadrilaterals whose two sides are parallel, while other two sides need not be parallel. So, every parallelogram is a trapezoid, but while every trapezoid need not be a parallelogram. For example, this is a trapezoid, but not a parallelogram. So, this is an example of a trapezoid. This is an example of a trapezoid. Okay, these are trapezoids. So, let us see what we do here. So, here is the function. Now, what is the idea? So, here is my x1, here is my x2 and so on. So, what I do, at every point I draw the function values, I go up to the function values on the graph, and in x2 I go up to the function value on the graph. From x3 for example, I go up to the function value draw up to the function value, draw up to the graph. Now, you see I have two sides parallel, but I start joining these 2 points on the graph. So, I have joined a and x0 and fx0, I have joined x1 with x1 fx1. So, I have joined, so this is x0 fx0 and with x1 fx1. Here I have joined, here I have joined. You see, when I am doing this, I have very little area left. I have some under the curve, very little amount of area gets left. So, there will be always an error, because you are trying to estimate, there will be always an error. So, you have a trapezoid here which is of this type. So, each of these trapezoid, for example, this trapezoid has a base. So, for example, I will call this as y0, this length as y1, this is y2 and this is y3 and so on. The function values basically f of x1, f of x2. So, basically I am calling them y1, y2, y3 just to keep in mind that every time I need not have a function given to me, it could be just some x and y's, and so that is why we are calling it as this one. Now, what is the area of this, say this one, this rectangle, this y which has parallel sides y1 and y2? How do I find? So, let me look at it this way. So, this is my delta x, this is my y1, this is my y2. So, what is the area? Just draw perpendicular here. So, that will this part will be same as y1, is because now it becomes a rectangle, and this part becomes same as delta x. So, here the area of so So, this part is now y1 and this part is y2 minus y1. Now, how I find the area? So, first I find the area of the rectangle, then area of the triangle and sum them up, that is the idea. So, area of the rectangle is delta x into y1 plus or y1 into delta x, if you are more I think that is more comfortable way of writing, people might just get confused. So, it is y1 into delta x plus area of this triangle. So, it is half of delta x into or y2 minus y1 into delta x, half base into altitude. I am just writing it, you can write like that, I am just writing it so that it looks much more cleaner. Oh shit. Now, what does this give me? It gives me y1 into delta x plus half of y2 into delta x minus half of y1 into delta x. So, it simplifies into half of y1 into delta x plus half of y2 into delta x, and so a beautiful formula comes out which says that this is nothing but half of delta x into y1 plus y2. So, once you know about one of them, you know about the other. So, the ith trapezoid, so this is the area of the second trapezoid. So, area of the ith trapezoid so what is the area of the ith trapezoid? The area of the ith trapezoid is given in a very simple way. It is just the same thing, half delta x, and you know what to do, yi minus 1 plus yi. Just replace 2 with I and 1 is of course 2 minus 1. So, it is I minus 1. So, now how am I going to estimate this integral, right? So, basically what I am going to do, I am going to add up these n areas, n trapezoidal areas, and say that that is my estimate. So, here we have again rubbed and got the picture done again. So, let us write T as the total trapezoidal area, T, the total area of the trapezoids, total area of the trapezoids under the made by the trapezoids, or just total area of the trapezoids. So, T of course is like this, half of delta x, which is of course common in everything, y0 plus y1, first rectangle, plus half of delta x, y1 plus y2, plus so and so, plus half of delta x, yn minus 2 plus yn minus 1, plus half of delta x, yn minus 1 plus yn. So, that is clear. I just summed up all the n rectangles. Now, if I sum them up, you see all of them, this half and half adds except the end points yn and y1. So, yn and y0. So, I have delta x into half of y0 plus y1, it is a neat formula, plus yn minus 1 plus half of yn. So, this is the trapezoidal rule, that this integral a to b fx dx is, it is very easy to implement, is approximately given by t which is nothing but delta x into half of y0 plus y1 plus yn minus 1 plus half of yn. So, let us take an example from Thomas and Finney and sorry, I keep on telling Thomas and Finney, it is now called Thomas as calculus, and show you how this can actually be done. So, we will discuss first of an integral which is very well known. You know how to compute that integral, it is very simple, it has an antiderivative, but just to check with you that how effective this method is. So, for that we are going to consider this integral say from and you know what the answer is to this. So use one, so I will compute this by using the trapezoidal rule. So, you see the whole point is that even for such functions you do not bother about antiderivatives. Let us see, this of course you know what the antiderivative is. So, we will make a check of what is the error. Now, let me take n equal to 4 points. So, divide this interval between 1 to 2 with n equal to 4 points. So, my n is 4, say you could make it 5 or 6 or 7, does not matter, n is 4, and this would imply that delta x, so delta x would be anyway small, so it will be 2 minus 1 by 4, so it will be delta x would be 1 by 4. So, 1 by 4 is quite a small length, you could make it smaller of course, that is a different issue. And so, now if I go by the trapezoidal rule for this, I use this formula. So, n is divided into, so what have I done, however in this particular case this is 1 to 2, it is partitioned into by 4 points. So, 1 plus 1/4, right. So, it is 5 by 4th, 5 by 4 plus 1/4, it is 6 by 4, and 6 by 4 plus 1/4, 7 by 4, and 7 by 4 plus 1/4. So, the points we have given is basically we have divided it into n is the 4 intervals that we have divided into 1, 2, 3, 4. So, we need 5 points. So, basically what you do, you have to know what is y0, what is y1. So, what is y0? It is x0, that is 1 square 1, y1 and also y2. So, you have to know y1, y2, y0, y1, y2, y3, y4. So, 4 points up to y4, y3, y4, y3 and y4, these points have to be calculated. So, I am not calculating it, I am assuming that okay, such a calculation can be done, you can easily do it yourself. I will like to tell you to do it yourself rather than relying on my calculations. So, this can also be written in a slightly different way. You can take for example del x by 2 out and make a more effective writing. You can write this as y0 plus 2y1 plus 2yn minus 1 plus yn. So, here also you can write in the same way. So, you put del of x is 1/4. So, 1/4 by 2. So, 1/4 divided by 2 is 1/8 and that 1/8 into 1, this is 1 plus 2 into y1, y1 means 5 by 4 whole square, which is nothing but 25 by 16 and so on and so forth. So, if you do that, in this case t turns out to be as given here, it is 75 by 32, which is a rational number, which is now expressed in decimal, is 2.34375. So, it is a terminating decimal. Now, but this is a number that we have got. but what is that integral? So, if I compute the integral, then this integral will turn out to be this x cube by 3, and that you raise down from 1 to 2. So, it will become 2 cube by 3 minus 1 cube by 3, which is 8 by 3 minus 1 by 3, which is 7 by 3. 7 by 3 is also around the same sort of number. So, what you can now do, basically you can, so there is something called relative error. Relative error means what is the error per unit. So, basically 75 by 32 minus 7 by 3 is absolute error. So, what is the error? So, if I calculate it out, what would it come? So, I am just writing it down. I am just not getting into. It will become 75. Just maybe I should do the computation. So, 75 into 3 minus 32 into 7 divided by 32 into 3. I think there are much more expert computation is on 1 by 96. So, it is 1 by 96 and good, it is 1 by 96. So, basically now this is my error. You see the error is pretty small, not very large. Maybe you can improve it by taking more points. And you see that this error, there is something called relative error. This is like a unitary method. Relative error means that nothing but 75 by 32 minus 7 by 3 divided by 7 by 3. So, it is equal to 1 by 96 divided by 7 by 3, which is nothing but 1 by 96 into 3 by 7, and that turns out to be 3 I can cut. So, 1 by 32 into 7, 1 upon 7 to the 2 to 4, 2 to 4, right, 2 to 4, yes, 1 upon 2 to 4. So, relative error is 1 upon 2 to 4, which is, you see, pretty small. So, this method is robust in some sense, that okay, it is easy to implement, it gives you, of course, there is a chance of improving this method, but this is pretty decent. So, let us just show that okay, if I take as delta x as n goes to infinity, that means when delta x, this length would go to 0. You can just look at the definition of delta x is b minus a by n. So, as n goes to b minus a is fixed. So, as n goes to infinity, delta x goes to 0. So, as delta x goes to 0, that this this t thing. So, t obviously, t can be written as a function of delta x, t is actually a function of delta x. So, what we want to show is that limit of t delta x is delta x tending to 0 is actually the integral, and that would tell you that how effective this method is. So, once we do it, we will show you what happens if I do not have an exact function, but just have a list of values y1, y2, yn, or what can we do about it, how we handle it. So, let us just prove this part of it. So, what can I do? How do I write it? So, my t, I can rearrange the t as follows, right. I can rearrange the t as follows, as no, not half, how can I have half? I can take this y1, y2, all these things which are. So, what I do, I put y1, y2, yn into delta x, just rearranging what I have known for t, delta x plus half of delta x into y0 minus yn, because yn was half. So, yn delta x minus half yn delta x is half yn delta x. So, that is what you do, but this what is y1? What y1 is f of x1, y2 is f of x2, yn is f of xn. So, I can write this as summation f of xi delta x. So, this is nothing but the Riemann sum plus half of delta x into f of a minus f of b. Delta x, okay. So, now as delta x goes to 0, so t, you can see whatever we say and do, t is essentially a function of delta x, because these are all fixed numbers. Delta x is under your choice, is because of how you choose the n. So, now as limit this happens, then what happens is the following. This is nothing but the Riemann sum. So, as delta x tends to 0, this limit, so maybe I should write it down, this is nothing but the integral, or even if you do not bother about the integral, it is just the Newtonian limit, because we are looking at a function which is continuous and non-negative. Continuity of the function is guaranteed, we are not going to write continuous function everywhere. So, so, what does this show? This shows that this is nothing but integral a to b fx dx plus 0, this is 0, that limit, and that is exactly what we intended. Limit of this is this, which is nothing but obviously at the end integral a to b. Now, I want to tell you that suppose you want to record the temperatures of say today. This is an example, give the specific numerical example given it there in the book of Thomas's calculus, but you do not need to really bother about too much numerics, because you can put in the numbers yourself. See, for example, if I get something like this, that, and that is what would we have. For example, in engineering design and many engineering problems, you get this x versus y. For example, you are looking at the time and the speed of a train, then you want to find the average speed of that train over a given period. So, or this is how do meteorological office decide temperatures? So, they decide, they never give you, they record the temperatures, but the overall temperature of the day, the average temperature is done through this method. So, here is your time t and this is your temperature with capital T, and the temperature is a function of the time t, and that is a continuous function. Let us write it as f, sorry, and this is a continuous function of the time. So, what you have, let me call it, so the values of t are given, t at time t equal to x0, x1, x2, xn. So, you have recorded. So, each hour you have recorded, say n hours, for n hours, so for n gaps, each n hour you have recorded, starting at time t equal to 0, ending at say the nth moment. So, this is your time x0, this is time x1, time x2, and time xn. So, it will be temperature would be given as y0, y1, yn. Then it is the same procedure. It is just the same procedure, write t equal to this. So basically once you know the t, so you know that it is a to b fx dx, and if you want to find the average temperature, is nothing but divided by b 1 by b minus a. That is it. You can try this out. So, there is a let's give you an interesting experiment to do at home. Those who have a thermometer at home, fine. Those not, go to the net. I am assuming that a lot of you have an access to the net. Those you do not have, try to do something else. Maybe you have to innovate something which I can't tell you right now. For those who have the net, the idea is this following: just Google. Suppose you live in a city. For example, here it is Kanpur, which could be in Delhi, whatever you want. So, you say at every time, see the time, temperature at time, you look at this time. So, they will give you temperature at this time, now current time you see record. After 1 hour you can see the Google record 2 up to midnight, and then you can use the same procedure yourself and tell people what is the average time and what is the average temperature. You see how much fun it would be. Thank you, and next we are in the next class we are going to speak about another rule, which is the Simpson's rule, and end our discussion of integration. Thank you very much.